Okay, just to know, we're waiting for you inside for our next talk.
Speaker.
Speaker. Дай на български.
Хайде.
Моля, заповядайте в залата. Готови сме за следващата лекция.
Очакваме ви вътре.
Да, може да си влезете с кафенцата, само не заливайте съседите. Да, заповядайте, има много свободни места.
Остават 30 секунди до началото на следващата лекция. 30 секунди. Остават 15 секунди до началото на следващата лекция.
Остават 45 секунди до началото на следващата лекция. Остава година и половина до началото на следващата лекция.
На следващата конференция. Please welcome.
Are we online? At least? Okay. And welcome back after the first coffee break.
Get ready for our second speaker who has been programming since 2003.
Dr. Ilian Iliev works as software engineer at Lifesum, a digital health company where he actively works on building new APIs and transforming the legacy monolith into a modern microservice-based systems.
He is a big Python fan. He is a big Python fan.
A Python fan, yeah.
Python fan, yes, for its simplicity, power, and flexibility. Outside the tech world, he loves the sea, snorkeling, fishing, and traveling with his family.
Today, Dr. Iliev is here to tell us about the soft skills vital for future developers.
Please applaud
Ilian Iliev!
Hello? So, beyond the for loop. Usually, when you start learning programming, you pick a language, it doesn't matter which one, and then you start learning a few things, the basic data types and the control flow. And the control flow, that's like if, else, for loop, and once you have this, you know everything you need to write a working software. There are a lot of things, as you can see outside this oval, there are a lot of other things that will help you, that will make you a better developer, but those things are often, like people learn the basic of the for loop and they start learning the things around, which is great, it's helpful, but they miss other vital things. And during my career, I have seen a lot of developers who has knowledge of how to write code, but at the same time, they lack knowledge of other pieces that are around the code. And being a software engineer is not just about writing code, it's about a bunch of other things. I want to make a chess analogy here. So you have learned the for loop. That's like learning the rules of chess. And once you learn the rules, you can play with people, you can play with your friends, you're having some level of fun, you can even win some games. The problem is that once you start playing against stronger players, you often end up in unexpected situations. Everything is going good, you're developing, everything is awesome, and then 5 moves later, you have half your pieces gone, and you're like 2 moves away from a mate. And in software engineering, that's something that can also happen if you don't know the basics around how to develop software, around how to work. So we'll talk about the combination of tech and soft skills that I find not only vital, but I find people struggling to achieve or like just missing them in their journey. First thing, learn to set up your environment. That's like step A. Okay, you know how to write code, but you need to be able to fully configure your environment so you can So you can feel at ease when you're writing code, when you're doing stuff. You need to be able to easily express yourself in the language of your choosing. I had a case a few years ago. A colleague of mine comes and says, oh, I'm having a problem with this test. Can you help me? So I go there. We see the error from the test. It's not really clear what's happening. So I'm like, OK, let's run it in debug mode and see what's going on. And he's like, oh, I can't do it. Why? Because I don't know how to set it up. OK, you're a developer with several years of experience, and this is the software we're working on every day, and you can't debug it. That's quite problematic. So part one, picked an IDE. Tools are good for writing. Back in the days when I started programming, I used to have Notepad++ or something like that. There was no code highlighting. There are a lot of problems with it. Nowadays, we have good integrated development environments. They come with highlighting. They come with a lot of tools that will help you run code, polish code. There are even quite a lot of free options. So pick one, speak with your peers, speak with your colleagues, pick one that's right for you, and start learning how to use it. Yes, Vim. Vim is not an IDE. Probably someone will kick my ass outside because of this. Vim is not an IDE. Vim is a great tool, but Vim is not for juniors. The problem with Vim is that it has quite a high learning curve, and also to make it work as an IDE, you have to add a lot of plugins, you have to configure it. If you have someone who will help you do that, someone who will guide you through the journey of like getting good at Vim, that's great, pick Vim. If you're not sure what to do, don't use Vim, probably because you won't know how to exit it. Step two, try to write visually appealing code. By visually appealing code, I'm not using the term clean code just not to be confused with a book that I'm sure you all know. Look at this. This is a simple example that if someone here knows Python, this is not how Python should look like. Languages have their conventions, have their ways of how to be written. Also, this is terrible. There are like a bunch of lines of code that are commented and left out. They're like, imagine that you're applying for a job, or you're just submitting a PR and your peers are opening your code. Their ID turns red and all covered with warnings because it doesn't look properly. This is not nice. It's hard to read. It's troubling. So how to write visually appealing code? First, use some formatters or linters. All modern languages support those. It's easy. You just run it. It makes your code look beautiful. It makes it easy to read, not only for you, but also for the people that are going to review it and use it later. Use blanks to separate logic blocks. Add comments in the right places. Do not leave a mess. What we saw earlier, like some commented code left there. Why was it? Was it ever used? It's OK to do that while you're still trying. If you're testing stuff, you're writing some code, you don't know if you're going to use it, yeah, just comment something, maybe you'll back to it later. But once you want to submit this for other people to use it or review it, don't leave the mess. And follow the language community conventions. They're not that complex. It's like, oh, use this type of casing for functions. This is how you separate methods. This is how you put brackets if you have so. This is how you put spaces. It's nice, and it helps other people read it. Read error messages. That's probably the most troubling thing for junior developers. This is the screen which you often will see if you work with Django. Django is a Python web framework. And junior developers, when they see this screen, they're usually, oh my God, something is broken. I don't know what happened. Yeah, maybe you don't know. The biggest problem is that they just throw it and say, oh, I need help. No, just read the error messages. It says exactly what's happening. It's not that hard to read it. Sometimes you get a stack trace, and stack trace can be confusing. You get a stack trace with like 30 frames. the last frame that usually indicates the error is something that is super cryptic. It's outside the code you wrote, so it's like, ugh, what happened? Read the whole stack trace. It takes less than a minute, and 99% of the errors that you experience will be solved just by reading the stack trace and understanding how the flow goes. Learn to debug your code. And not only your code. Learn to debug the code you're running together with everything that's running around. What's the problem? As we said with the stack trace. Oh, it's breaking in some third-party library. Oh, but it's probably breaking not because of the library, but because you're doing something wrong. You're passing the wrong type of arguments, or you're passing something that you shouldn't, or you haven't initialized it properly. Learning to debug code is vital. It saves a lot of time to do it. And print debugging is not debugging. Print is useful for testing stuff. Debugging means you need to run the program and have step-by-step, you go one function after another, one call. You see all the types, you see all the variables, you see their values, you see how it goes, you see the loops. This helps solve problems, and not only to solve problems, but it also, when you're doing this, you may actually notice something that you have missed. Learn a framework. As a junior developer, you want to write code because you want to achieve stuff. You want to make something, because if you have to write like 5 libraries to make or like 5 files to make an HTTP connection, that's problematic, and of course you're not going to enjoy it. And we want to learn programming to enjoy it. So learn a framework or a library. They save you code, they help you achieve more in less time with less coding, and this way you're getting more fun. You'll be more hooked in the whole programming thing. And also, while you're learning frameworks, it will help you to, you can dig inside the framework. You can see how it's implemented. Sometimes it's complex, sometimes it's simple, and it just saves you time. But seeing how it's implemented helps you understand how to do it yourself, or what things you have missed when you, if you want to do it by yourself, like some security aspects. Changing stuff and seeing what happens. This is how you usually start. You get some working program, or like you copy code from Stack Overflow that's supposed to solve your problem. You put it there, but if you don't understand it, what will happen is that 2 weeks later, someone from product will come to you and will say, oh, I want you to modify it so it does something slightly different. And because you don't understand the code, what will happen is like, oh, I don't know how to do that. So change stuff and see what happens. It's not a problem if you break something, as long as it's not production environment. Break it, test it, change something, see if you can achieve more with it, see what other capabilities are there. By playing with code is how we learn. Code without tests is broken by default. Oh, that's a tricky one. Learning test-driven development is hard. At least for me, it was really hard. Like everyone was explaining to me the idea of, oh, you write the test first and then you write the code first. And I'm like, if I write test and I explain what it should do, doesn't that the same as writing the code? So this is hard. Go ask someone. I'll leave my contacts at the end of the presentation. Ping me if you want. There are ways to write tests in an easy way that will help you achieve code. But please find a peer if you can do it by yourself to help you. Or look at existing tests in the tools you're using. Look at few tests, you'll see what's happening, how they're built, how they're verifying the behavior without actually copying the code in the logic. This saves a lot of time. This saves problems as regressions. I'm sure all the QAs here will be happy if you start writing tests. Version control. In my company, we used to hire a lot of people coming from different universities or academic environments, and they're good. They're writing code. They understand problems, but they have no idea of version control. They just pile files and files and files and make changes, and then send this in a zip file. It's like, okay, and what's that line here? What's the reason for this one? Oh, I don't know, I wrote it like 5 months ago. It's like, yeah, but if you had version control with proper error, with proper commit messages, you remember what this change was about. This is not the right way to learn Git. But if you're a junior developer, just run 6 simple Git commands. Learn how to commit code, learn how to make branches, learn how to merge it. It's enough for you to start. Git is big. Git can do a lot of things, and it's good to learn it properly. But for the start of your journey, this is enough, and this will open the door for you to move forward. Contributing to open source. A lot of junior developers are afraid to contribute to open source. But it's actually pretty good, and it's not that hard. There are a lot of projects out there, and the good thing is that a lot of those projects actually have tickets that are like junior level. Maybe it's writing documentation. Writing documentation is boring, but will help you learn the tool. And to write documentation, you need to learn the code, so you'll see how things are built. You'll learn some good practices. Also, even if your PR is not accepted, that may be a valuable lesson to you. I remember some years ago, I was contributing to a project. We discussed it, I wrote the code, everything was fine. I was like, okay, we're close to delivering. And then one of the top maintainers of the project came and said, no, it's actually working as intended. It's just not documented properly. It was a weird database transaction case. Start asking why. There's something that's called the 5 whys. It's an interrogation technique, and the idea is that you need to ask why 5 times to learn the root cause of a problem. Because when a product person comes to you and says, oh, I want this feature, of course you want to write code. You're a developer. You can sit down and write it in 2 days and then deliver it, and everything is great. But at the end, it's not working properly. So start asking why. Why are we doing this? Why do we want to achieve this and not something else? Why are we building it now and not later? All these questions will help you find what's the root cause, what's the actual problem that we are trying to solve as product and developers and to build the right feature or to fix the right issue. How to solve problems. This is tricky. When you start your career as a developer, you'll face different problems, and it's hard to know how to, you don't know everything, so you need to find a way to solve those. Think. Give it time. You can't see problem and say, oh, I don't know how to do it. Give it time. Think about it. Spend a few minutes. Maybe just step out of the computer, have a coffee break or something, and come back. When you have a fresh look at the problem, it will help you understand it better. Get a rubber duck. Not as big as this one. That might be hard to fit at the office. Actually, one of the sponsors here, they're giving these small rubber cars. It's pretty good. So by taking some object, or better, a person, just by explaining, just by saying what the problem is, just by explaining what you think about the solution, you realize things that are not, that you have missed. You realize that, oh, it's actually something different. I can solve it in a different way. Ask for feedback. Ask for feedback from your peers, from your friends, if you have managed to land a job at a software company, ask your colleagues for constant feedback. Sometimes it may be hard, like, oh, that code is bad. Don't think about when someone is saying, oh, your code is bad. Think about what they actually saying. They'll usually point problems like, oh, this is a security concern. Oh, this is not performing properly. Oh, this is actually going to take a lot of resource. It will be fast, but it will be quite expensive to run. So ask for feedback. One more thing, communication skills. Being a developer is not just about writing code. Part of your job is to gather requirements. Part of your job is to speak with not only with different developers, but also with different product people and management. You need to learn how to communicate and explain and to convert technical language to product language and vice versa. You need to understand what are the roots of the problem. You need to communicate it better because, oh, you have learned you have learned design patterns. That's great. And then comes the product person and says, I want this feature. And you're like, oh, we'll use this design pattern and that design pattern and we'll build it right. And like, they don't really care about that. They care about the feature. And that's what you should ask about. Why are we building this? How should we build it? Is it going to work? What happens if the user don't have permissions to see that? And all these things. Last thing. This is actually one of my professors at the university said that. Ignorance is not a problem. Unwillingness to learn is. So be open for things that you don't know. It's not a problem. We don't know everything. I definitely not. I'm learning new things, hopefully every day. It's important to try to learn. It's important to try to advance, to get better at the things like, oh, I don't know how this works. Okay, I'll research, I'll ask something, I'll get some opinions. Maybe that's not the best way to do it that I'm trying, but just keep moving. That's it. Thank you.
Okay. Do you have any questions? Do not hesitate to ask questions, and you can win wonderful Dev Challenge accepted t-shirts given by our wonderful speaker. So, do you have any questions?
If you're too shy to ask questions, just find me outside.
Yeah, you can find him outside, but
I don't bite.
Okay. So, we can continue. Thank you very much once again. That was very interesting. Even I understood what you were speaking about.